Hello and welcome everybody to my video lecture about protection in electrical power systems. Today our focus is on protection concepts and network reliability, and we look into fault dynamics. Let's start with a very simple radial network where one feeder is protected by one relay and we assume a fault at the end of the line. So we have the network, a fault occurs and immediately the current goes up and the voltage on the bus bar drops. So then the timer is started. After, for example, 0.4 seconds, the circuit breaker is opened and we trip. The current resets to the original value and the voltage is healthy again. The same happens if the fault is at the beginning of the line. So it is the fault occurring with the timer starts to run. After this, the timer has tripped and the fault is cleared. Now, if we want to have a more sophisticated approach, we take one feeder but two relays, one at the beginning of the line, the other one at the end of the line. And we look again at the fault at the end of the line. The fault occurs, the current goes up, the voltage goes down, and this goes on for 0.4 seconds again, and after this the fault is cleared, the circuit breaker opens and the system resets. What happens if we have the same network but now a fault at the beginning of the line? So again, the fault occurs, the timer starts, but now we have, according to the principle of time grading, a higher tripping time for 0.8 seconds. After this, the circuit breaker opens and the whole system is at a regular voltage state at least. But one feeder is lost. Now let's look at a radial network with an automatic recloser and a rezip recloser. This is a new type of protection device and a fault at the end of the line. Let me give a few words about this principle of the rezip recloser. A rezip recloser is a device that is not only capable of time-graded protection, but also of logically graded protection. And we see how it works. So we start at the fault with the fault at the end of the line. The fault occurs, the current goes up, the voltage goes down. And after 0.1 second, all of these reclosers and the auto recloser AR at the end, they trip out immediately. So we have a complete loss of all substations in this line. Now, after 0.4 seconds, an automatic switching sequence starts. We start at the beginning of the line, where after 0.5 seconds, this auto-recloser relay closes and energizes the line, including the next bar and the next rezip auto-recloser. So what happens here? The auto-recloser sees a voltage coming, waits half a second and closes and passes the voltage on to the next bus bar and the next rezip auto-recloser. Here, the same sequence occurs again. After half a second, upon receipt of the healthy voltage from the busbar side, the rezip auto-recloser closes, but this time we close on a fault. We have a trip on close and we trip immediately. So now we are left, and this is the final state of this sequence of an automatic recloser with a rezip recloser and a fault at the end of the line. So what can we see here? First, the first bus bars are energized. The bus bars downstream of the fault are not energized. That is not possible in this type of network configuration. And the bus bar, that means all customers in this network, they experience two voltage dips, which with the use of proper equipment are sometimes maybe less than 100 milliseconds. So they are more or less without any harm to the customers. Now we can see the same, to repeat it again, for a fault in the middle of the line. The fault occurs and all afflicted auto-reclosers trip immediately. And now, after a time of 0.5 seconds, the reclosure and the passing on of the voltage starts again from the left side. The next rezip auto-recloser sees the incoming voltage. After half a second it closes, but unfortunately it closes on fault. Again, the current goes up, the voltage goes down, you trip out immediately, and that was it. Now, for the beginning, a fault at the beginning of the line, we have a very similar occurrence. So it is the fault coming up. The first auto recloser trips immediately, and after its recloser time, it recloses on the fault and trips out with a definite fault. And again, this was it. The last fault I would like to show you how it works out is a fault behind a fuse. So we have fuses which are before the medium voltage to low voltage transformers usually, and they protect this transformer. We have a fault behind this fuse, the fault D. What happens? It's a very rapid fault, a very quick clearing time of a few 10 or 20 milliseconds, and it does not start any one of these auto recloser devices. And finally, the one faulty transformer has tripped out and all the rest is still energized. So this is fantastic, good protection behavior. But now, as you all know, such radial networks can be improved by adding tie breakers at, for example, the end of the line. And here we have such a structure. We extend it by adding a tie circuit breaker at the end of the line. And now we can energize a faulty line from the rear side. Let's see how it works. So we finish with a fault at position C, as we have seen before. One auto recloser is open, all the others are closed, and now we re-energize the line from the rear side. So this is the moment when the tie breaker closes. Now these rezip devices wait again for half a second until they reclose from the right towards the left. So they reclose, pass on the voltage to the, from your side, left-lying circuit breaker. And this one, after half a second, closes again, but unfortunately, as you see here, it is a trip on close. That means the current goes up, voltage goes down again, and after a short time, this one trips out again. And after this trip on close, we reach the final status of the network. That means all circuit breakers are closed, except for the one that energizes the faulty substation with its attached line. And you see the voltage. For all the customers, we had 3 voltage dips, which are very short, no long voltage dip as in overcurrent time-graded protection, and we have a healthy network more or less after this. So this was the first lecture about protection concepts and network reliability. And if you like this, please go on to the next section in the playlist. Thank you very much.